Hi dear students and viewers, welcome back to our channel and app Anvinay Kumar Basics of Physics. Dear students, in this video we are going to discuss about the velocity versus time graph problems. One of the most important topic for competitive exams, how the problems will be given in the graphs with respect of velocity versus time graph. Let's discuss. Dear students, if you are first time watching my channel, then subscribe my channel. Before going to subscribe my channel, then go to the playlist and check all the playlists. If you can satisfy with my videos, then only you can subscribe. And if you want to write free online exams, then download the app Anvinay Kumar Basics of Physics from Google Play Store. Okay, without late, we are going to the topic. Velocity versus time. In these graphs, in that graph at any point that will use the instantaneous velocity, that is the thing you have to remember, and slope of the graph will use the acceleration. In velocity versus time graph, the slope of the graph will use the acceleration. And third one, the area covered by the graph in VT graphs, that will use the displacement. These are the main key points you have to remember to do the problems in case of velocity versus time graphs. So let's go for the topic. We have one problem on the board is there. Let's see here. With help of the given velocity, displacement in the first 3 seconds and acceleration in the first 3 seconds, we have to find out. With the help of the given velocity, find displacement in the first 3 seconds and acceleration in the first 3 seconds. So one graph it was given. Along the y-axis we are taken velocity in terms of meter per second, and from the origin, that should be here, we are taken velocity is positive. From the origin downwards, velocity is negative. So -10, -20, -30, like that. Clear? So what you have to find out, and in this case what it is, along the x-axis the time will be given 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, like that. So we want to find out the displacement and acceleration within the first 3 seconds. That means what? 0 to 3. Clear? So displacement, already what I told you, the area under the graph will use the displacement. That's why here you can observe this is the 0 to 3 seconds. So this is the area covered by the graph. Clear? This is the total area covered by the graph that will use the displacement. What is displacement? So covered in what you say in VT graphs, what you have to say, area under the graph will use the what? Displacement. The area under the graph will use the displacement. That is you have to remember. So here you have to remember it is like a triangle. Clear? So at the time here what it is, 0 seconds, and this is 3rd second, and 0, and this is what? 30 meter per second. This 30 is nothing but what? Height, and this 0 to 3 is what? Nothing but base. That's why here what we know, area of triangle, what is the formula? Half into base into height. Here what is the base? Just now only we discussed what is the base? 3 into height. How much is a 30? So 2 ones are 2 15s are is 45 meters. Displacement covered is what? 45 meters. In this way we will find out the displacement within the first 3 seconds. Clear? And next one is here, what you have to find out, acceleration in the first 3 seconds. Just now only we discussed what it is, the slope of the graph will use the acceleration. That's the thing you have to remember. Slope of the graph. Which graph? VT graph. That will use the what? Acceleration. That's the thing you have to remember. So what is the formula here? Slope formula, A is equals to here v2 minus v1 by t2 minus t1. Clear? What is t1 here? t1 is 0 seconds and t2 is what? 3 seconds. And obviously when t1 is 0, velocity is what? 30. That's why here when t1 is 0, velocity is what? 30 meter per second. When t is 3 seconds, then the velocity is what? Yes, what is 0? 0 meter per second. Now you substitute the values, you may get the acceleration. A is equals to v2, velocity at 3 seconds, what is 0? 0 minus v1, what is 30 by 3 minus 0. Then A is equals to what? Minus 30 by 3 minus 10 meter per second square. 3 ones are 3 tens are. A is equals to what? Minus 10 meter per second square. So in this way we will find out the acceleration and displacement. Clear? Let's see another problem. This is the another type of problem. Look here. Question should be like this. A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at constant rate b to come to rest. If the total time elapsed is t seconds, evaluate the maximum velocity reached, total distance traveled. A car accelerates from rest. Car is started from rest and that should be accelerated at a constant rate alpha, after which it decelerates, velocity decreases, constant rate beta to come to rest. If the total times elapsed is the t seconds, evaluate maximum velocity reached, total distance traveled. Okay, look here. To understand that simply here, it was given comparison between velocity and time. That is the you have to remember. Velocity and should be here time. So the velocity is increase at constant rate. When it is increase at constant rate, it means it is a straight line. Clear? After some time, it is again decelerates with constant rate. Clear? So now as it should be like this. A car accelerates from rest, here rest position, at alpha. Sometime it decelerates with the constant rate b come to rest. Clear? So from here I am saying O, A, B. O to A it is increase with constant rate and A to B it is decreases. In this case slope is what? Alpha, and is now it is beta. Clear? And this is what? Maximum velocity. This is what? V maximum velocity. And what you are saying, from O to A time taken is t1 and A to B time taken is t2. And what you are saying, total time elapsed is what? t1 plus t2. t1 plus t2. Then what you have to find out? First one is the maximum velocity and next one is distance traveled. Already we discussed what is distance traveled. The area under the graph will give the total distance. And how we can find out the maximum velocity? Let's see here. So for the first part, what is here? What are you saying? It is alpha. Slope is what? Here it is nothing but alpha. Here alpha is equals to what? At here I am saying it is some AC. What, right? AC by OC. AC by OC. Clear? Then obviously it is what? AC means what? It is equals to V maximum. That's why here V maximum by OC is what? T1. That means here alpha is equals to V maximum by T1. From that what, right? T1 is equals to V maximum by alpha. So this is the equation number 1. And similarly here now, similarly for the second part also we can write beta is equals to beta, that is the degree S. It should be like this. Clear? Then obviously what right here, AB by BC will write. AB by BC we will write. Sorry, AC. So now it is the sum here, beta, then AC by BC, AC by BC, clear? Okay, what is AC again? V maximum. Here minus it is increase, it will shows the decreases. So V maximum by BC is what? TT. From that, right, beta is equals to what, right? Beta is equals to V maximum by T2. That implies TT is equals to what? V maximum by beta. So this is the time taken from A to B. Now we are going to say that total time is what? T is equals to T1 plus T2. Then T is equals to here, what is T1? What is T1? V maximum by alpha. V maximum by alpha plus V maximum by beta. That implies T is equals to what right here? V maximum is common. Then what right here? 1 by alpha plus 1 by beta we can write. So from that, here we need some space. That's why I'm erasing this one. Then what it is? T is equals to V maximum of 1 by alpha plus 1 by beta. LCM is what now? Beta. So what is beta plus alpha by alpha beta. Then what right here? V maximum is equals to what right here? S alpha into beta into T by alpha plus beta. This is the expression for V maximum. That is the first we have to measure. The maximum velocity what is? Alpha beta by alpha plus beta. And the second one is what? Here displacement we have to measure. What we know? Area under the graph gives what? Displacement. What is displacement? Clear? That's why here I am going to write here area is nothing but displacement. That is what here? Half into base. Here what is? This is the area covered, total area covered. Okay, that's why here time is what here now? Base is what? Time into height. Height is what? V maximum. V maximum. So already we derived expression for V maximum. Already it is alpha beta by alpha plus beta. Alpha beta by alpha plus beta. Then what you get here? 1 by 2 into T square. Alpha beta T square by alpha plus beta. This is the displacement covered. Let's see another model. Velocity time graph of a particle moving in a straight line shown in figure. Find the total distance covered by the particle. He was given one graph. The particle is moving in this path O, A, B, C, D. This is the path followed by the particle. Now what do you have to find out? We have to find out the total distance covered. Total distance covered. Already we discussed what it is. The area under the graph will give the distance. That's why here we have to find out the area under. This is what we are finding here. That should be we have to find out it. So as well, the graph consists of what? Velocity in meter per second on y-axis and t is along the x-axis. So now first we have to divide the area under the graph should be into number of parts. So this is the first one, and this is the second part, and this is the third one, and again that should be divided into two parts like this. So this is third one and this is now fourth one. Okay, and next one is this one, fifth one. So we have to find out the distances individually, and after the combining all this, what we get? Total distance covered. Total distance covered. That's why here, okay, first thing, for first what I am saying here, that is SOA, distance covered along the OA. So how it is? It is like a triangle. So 0 2 0 2, and this is what it was given 10, and it is now 10. That's why here what write? Triangle of base into height. Then what it is? Half into base is 2 and height is 10 meters. 2 cancel. Then what you get? SOA is what? 10 meters. That's the first part. And second one is distance covered under the graph AB. So in this portion we have to find out. That's why here I am going to write SAB, and that should be here like a rectangle like this. Clear? Then what right here? Length into breadth, length into breadth. So here what is 2 and this is the 4. 4 minus 2, 2. 2 into, and breadth is what? 10. 20 meters. So this is the first one and this is the second one. Now third one. What is third one? So this is the BC. I am saying now some it is whatever, maybe I am saying it is E. BCE. The area under the BC we have to find out. That is nothing but sum of the 3 and 4. 3 and 4. Clear? That's why here I am going to say SBC is equals to here. First one is like a triangle. What is BCE? BCE is the first one. So that's what we write. What we write off into base is here 4, and it is now here 6. I think so. Yes, 0, 2, 4, 6. Okay. So now what it is 6 minus 4. 6 minus 4, 2. Clear? That's what is what? 2. And height is what here? 20, 10. 20 minus 10, 10. That's why we are right here. Off into 4 minus 6 or 6 minus 4, what it is? 2. 2 into height, what it is? This portion is equals to this one. 20 minus 10, 10. Plus, and this is again as well same length into breadth. Length is here 2 and breadth is 10. 2 into 10. 6 minus 4, 2, and this is what it is? 10. Then what it here? 2 to cancel. 10 plus 20, that is equals what? 30 meters. So that is what? 3 and 4. 3 plus 4. And now here fifth one. What is C? I am saying it is F. CFD. CFD. So what is SCD? Area under the CD we have to find out. Okay. CFD. It is like a triangle. Again what are here? Off into base. 8 minus 6, 5. 8 minus 6, what is 2. Okay. 8 minus 6, 2. And height is what? 20 into 20. Then what here to do? Cancel. 20 meters. So this is the distance individually. Below the OA, below the AB, below the BC, below the CD. So if you can find the all the sum of all these, we will get the total distance. Total distance. What is SOA plus SAB plus SBC plus SCD. That is what here? Nothing but S. How many is there? 10 plus 20 plus 30 plus 20. Sorry, 20. Okay, 20. Then what you get here? 10 plus 20 plus 30 plus 20. Then S is equals what? 10 plus 20, 30, 30 plus 30, 60 plus 20, 80 meters. So 80 meters is the total distance covered in this situation. Clear? See the next model. The velocity time graph of a body moving in a straight line is shown in the figure. The displacement and distance traveled by the body in 6 seconds are respectively. Options are given: 8 meters, 16 meters, 16 meters, 32 meters, 16, 16, and 8 meters and 18 meters. The particle motion should be like this. Okay, when it is at time 0 seconds. So along the x-axis, what we take? T in seconds. Okay, when time 0, the particle is at 4 seconds, and up to 2 seconds that should be in the same like that, same motion, uniform motion. And after that it is constant, it is comes like this. Clear? And after that here, when it is 2, 0, and when it is 4, yes, it is in negative direction, and again that should be in positive. Clear? So in this way we have to find out the distance and displacement. So now here this is the first part, and this is the second one, and this is the third one. So the area under these graphs should be distances or displacements. Okay, displacement is the vector, for that we have direction is there, but distance is the scalar, there is no direction. Okay, so I am going to say this is the first should be like this. This is the area under the curve graph. So time is 0 and it is 2 seconds and it is 4. Clear? So now it is like a rectangle. That's why here I am going to say, here for the first one S1 I am saying here, that is what, length into breadth. Breadth is 2 seconds and it is 4. 2 into 4, 8 meters. 8 meters. So that is what, plus 8. It is a displacement and this is distance. Okay, and now here for the second one S2, here again length into breadth. What is here? 2, it is 4 minus 2, and it is up to here minus 2. That's why here 4 minus 2, 2 into minus 2, that is what, here minus 4 meters. So this is what, here minus 2 and 4 minus 2, 2. So now it is the displacement. What is displacement? But distance is what, is 2 into 2, 4. This is the what, distance, and this is what, displacement. And S3, here what is 4, 6 minus 4 is 2, and it is again 2. That's why here 2 into 2, 4 meters. So that is the both distance and displacement. Distance is 4 meters and displacement is plus 4 meters. For S1, displacement is 8 plus 8 meters, distance is 8 meters. For the second one, minus 4 meters is the displacement and 4 meters is the distance. For the third one, 4 meters is the distance and plus 4 is the displacement. So now we have to write total displacement. That is what, plus 8 minus 4 and is plus 4. These two are cancelled, what you get, plus 8 meters. That is what, 8 meters is what, displacement. And total distance. Total distance is what? 8 plus 4, 12 plus 4. So 8 plus 4 plus 4, 16 meters. So very simple. For distance we can take all the positives, and displacement we have plus and minus is there. That's why here among the 4 options, first option is the correct one. So dear friends, this is enough for this video. I hope that. So if you can encourage me and support me, I will upload the more videos. That's why how to give your opinion as a comment. This is the only first part of the velocity time graph problems. In the next video I will upload the remaining problems. Okay, thank you for watching.